Hola, my name is Pamela. Welcome to my channel. Today I'm gonna talk about in the density measurement by differential pressure, 2 points are fixed in the tank or in a vertical pipe of the process, and a differential pressure instrument is connected to them directly or through a measurement chamber. As the difference in height in the liquid is fixed, the only variable that alters the differential pressure is the density, and as long as the temperature does not vary.
In the case of direct measurement of the mass content by means of hydrostatic pressure, HTG, hydrostatic tank gauging, where maximum accuracy is of interest, a PT100 resistance probe is used, which makes it possible to compensate for the difference in density obtained.
The differential pressure measured by the instrument is calculated with the first formula, and if the density measurement field should start at 0.8 to 0.9, and the instrument to be used has a margin of 0 to 100 mm column of water, the distance between the intakes is calculated with the second formula. Since the density reading must start at 0.8, the instrument must have the elevation of the first equation, since the minimum differential pressure is that of the second equation, and the maximum that of the third.
In the case of fluids that are not too clean, very viscous or corrosive, there is a risk that the connections to the instrument will become clogged or destroyed.
In this case, an air or gas and even liquid purge system can be used through two pipes placed inside the liquid, and whose ends are separated by a fixed distance. In the image above, for the normal installation, the separation would be 1 meter, and the instrument should have a lifting spring set at 80 mm of water column. In another system used in atmospheric pressure measurement chambers, the lower pressure branch of the instrument is filled with a liquid of constant height, which serves as a reference, whose density may be greater or less than that of the process liquid.
These differential pressure instruments have an accuracy of plus minus 0.5 to plus minus 0.1%, and can work with pressures and temperatures of 300 bar and 170 Celsius degrees respectively.
In the displacement method, a displacement instrument or torsion bar is used, similar to the one used in liquid level measurement. The float is fully immersed in the liquid and is externally balanced so that the torque developed directly represents the density of the liquid.
Is accurate to plus minus 1% with a density measurement range that can be as low as 0.005. The operating pressures and temperatures reach 40 bar and 200 Celsius degrees. The system can be used in clean liquids, not being suitable in sticky liquids or liquids that have suspended solids, since they could adhere to the float and distort the measurement.
Refractometers are used on clean fluids. The rotating prism model consists of a tungsten filament-like source that strikes the liquid at a certain angle, such that liquid reflection passes into refraction. The light beam is focused on a rotating prism that sweeps through the process liquid. The reflection that occurs when the light beam hits the critical angle is detected with a photoelectric cell, and the signal is amplified for its corresponding registration or control.
The refractive index can be related to the solid concentration of the liquid, that is, inferential to the density. A variant of this model sweeps the process liquid with a light beam transmitted through optical fibers immersed in the liquid. The light that comes out of the fiber is the greater, and the less that reaches the detector, the closer the refractive index of the liquid is to that of the fiber.
In the fixed prism model, the critical angle is determined by the ratio of shaded area light area of a detector that captures the light reflected through the prism. The optical detector is made up of 255 photocells that send pulse trains. The number of high pulses corresponds to the light area of the image, and therefore defines the position of the shaded edge. A microprocessor compensates for temperature variations, linearizes the signal, and outputs the units of concentration of the fluid.
Refractometers are not influenced by undissolved solids or dissolved air. Its minimum field of measurement is 0.004, and its accuracy is 0.001 grams per cubic centimeter. Sticky liquids or suspended solids can coat the prism, so it would need a periodic cleaning that can be automatic with intermittent steam. They are used in evaporators, in the concentration of black liquor in the paper industry, etc.
And well, this will be all for today's video. Don't forget to give me a like, subscribe, and share. I will upload videos every Wednesday in Spanish and every Friday in English. Adiós!